Sir, we are on live. We can start, sir.
Hello everyone, welcome to the Gate Academy. My name is Umashankar Sir, and in today's session, we are going to do the most important questions of theory of machines. All right, my dear. So, my dear, in this session, what we are going to do, we are going to do the most important questions of theory of machines, guys. Okay, most important questions of theory of machine. Okay, so all the live students, you can interact to me in the live chat section. In the live chat section, you can interact to me in the live chat section, right, beta? And if there is anything, you can ask me. So my name is Umashankar Sir. Before beginning with the session, I would request you that if you have not subscribed the channel yet, please do subscribe the channel. Hello, Shubham. Please do subscribe the channel and please like and share this video amongst your friends. Okay, so here we go with the very first question. So most important question that we are going to see for the GATE 2022 examination from the subject. So this is the first question in this session. Okay, let's see if we can solve it or not. Good afternoon, Shubham. Very good afternoon. Let's see if we can solve it or not. Please try to solve it. I am very sure that we can solve it, Buddha. I am very sure that you can solve it. This is the first question. This is the first question. Okay, so I am expecting some right answers from you guys in the live chat section of YouTube. Okay, let's see how many of us can answer it correctly. Read the question thoroughly and you can respond your answer key in the chat section. In the live chat section, you guys can respond to me. I hope the screen is visible to you guys. Please try it. I'm very sure that you guys can do it. I'm very sure that you guys can do it, Bida. Any answers? So a flywheel is used in a punching press if the cycle time required is 6 seconds and the stroke length is 125 mm. What will be the time required for punching the sheet metal of thickness 3 mm? Okay, so I think we are very well aware of this fact that the punching machine, in a punching machine, flywheel have some application, or we can say flywheel is being used in a punching machine, right? Flywheel is being used in a punching machine. Okay, so do we know it or not? I think we are very well aware of this, right? We are very well aware of this, right? We are very well aware of this. So in this is the question of application of flywheel in the punching press. So see, what is the idea behind it? So maximum, most of the time, flywheel, there are many questions that asked in the previous years of GATE, but they never touched this punching machine thing, okay, or punching press thing. So obviously, it is a good candidate of from where the question can be asked. Okay, so that is why I have put a question of this topic in here. Okay. So I'm very sure that you guys can answer it. So if you try it, please answer it. Any answer, my dear, any answer. I'm very sure you can answer it, beta. Answer kariye. I'm very sure that you guys can answer it, beta. Kariye, answer kariye. Answer kariye, beta. Any answer? Okay, I'll do it now. So what is being said in this question? A flywheel is used in a punching press. A flywheel is used in a punching press if the cycle time required is 6 seconds and the stroke length is 125 mm. And the stroke length is 125 mm. what will be the time required for punching the sheet metal of thickness 3 mm? Right, a flywheel is used in a punching press if the cycle time required is 6 seconds and the stroke length is 125 mm. What will be the time required for punching the sheet metal of thickness 3 mm? So we have a punching press, we have guys a punching press. If the cycle time required is 6 seconds, so what do we mean by cycle time? So we have a punch like this, let's suppose like this, and let's say, so what is the work of a punch? How do a punching press work? So basically a punching press, so we have some sheet over here, so let's say this is your die or something, and we have sheet placed over it, and this punch goes down. Okay, this punch goes down, make the cutting, and then it will go up, it goes up, right. So this completes a cycle, this is a cycle. Okay. So what is given? So a flywheel is used in a punching press if the cycle time required is 6 seconds and the stroke length is 125. That means, so one stroke is 125, and to complete a cycle, it requires to complete two stroke, one down and then again to its original position. So for completing two stroke, that is 250 mm, it took 6 seconds. Now, obviously, what will be the time required for punching the sheet metal of thickness 3 mm? So when this punching press, what is the actual time required for punching? So what is the sense of the question? So cycle time is when this complete one cycle, it goes down and comes up. And this, what will be the time required for punching the sheet metal of 3 mm thickness? So basically they are asking you that what is the exact time it took in punching the sheet. So if you have solved the questions of punching press in a flywheel, then you must have seen that we find cycle time and exact punching time. So basically this is the exact punching time they are referring to. So when you calculate this time, it will be 0.02 seconds. So it takes 0.02 second to actually punch the sheet metal of thickness 3 mm. So this is also we know as exact punching time. This is also we call as exact punching time. I hope it is fine to all of you. Now moving to the next question. If there is a doubt in this question, please feel free to ask me. Okay, can we now solve this question? Can we please try this question? So consider it a numerical ability question. So no option in here. You can give your numerical answer in the sheet provided. Sorry, in the YouTube chat. Please go ahead. I am very sure that you can do it. Please try it. Please try it. Very simple question of vibration. Post dam vibration, isolation, a very important concept. Very many questions have been asked of this context in the gate examination previously and also. And vibration is a very important topic. You see, every year you will find some questions of the vibration for sure. Okay. Now please try it. I am very sure that you can do it. I am very sure you can do it. Please try it. Please try it. I'm quite sure that you can do it. Any answers? So I'll do it. So if the force transmitted to its foundation by the machine shall not exceed 1 by 14 of the applied force. So what is given? Ft, the force transmitted shall not be exceed. So what is the limit to Ft by F naught? It is 1 by 14, right? It is going to be 1 by 14. So the limit to Ft by F naught is 1 by 40 it is actually. So the ratio of this Ft by F naught, that is force transmitted to the force generated is not to be exceeded by 1 by 40. So I think we know this is your transmissibility ratio. So what is the formula to transmissibility ratio when no damping is there? So when no damping is there, that means zeta is equal to 0, and this transmissibility ratio is then given by 1 minus omega by omega n whole of a square. Omega by omega n whole of a square. So from here what we are getting, let's see. So we are getting 1 minus omega by omega n whole of a square, okay, is equal to, so transmissibility ratio, so this is going to be 40. So we are getting omega by omega n square is equal to minus of 39. So this is not possible. This is imaginary number. So what happens when this kind of things come? So since there is a negative sign coming here, so we have to use the opposite formula of it, and we should use it like this: 1 minus omega 1 upon omega by omega n square minus 1. So whenever you are getting the imaginary number in the calculation, you may use this formula. Okay. So sometimes if you see in the books, it is written like this. Okay. But we get confused in it. So that is why I teach it in this way, that you try with this formula if you are getting an imaginary number. Here we are getting an imaginary number. So what you can do, you can just replace the formula, just multiply it by a negative sign, and then you can solve it. So this is going to be 1 by 40, and this is 1 upon omega by omega n whole of a square minus 1. Now you see we have only one variable. So from here we will be getting omega by omega n square. So it is going to be 40 plus 1, that is 41. That is 41. Okay. So from here, obviously, we can do root over 41. We can do root over 41. So let's see what we are getting, root over 41. So frequency ratio. So frequency ratio means they are asking you for omega by omega n. So root of 41, that is 6.403. So what is the answer to this question? 6.403. So any doubt in any question, you may ask me at any point of time. Now moving to the next question, third question. Now can we please try this question? Can we please try up this question? Let's see if we can solve this question or not. Let's try. Let's try. Let's read the question. So the mass of the rim of a flywheel is 604 kg. The safe centrifugal stress for the flywheel is 7 megapascal, and the material density is 7,200 kg per meter cube. The engine is running at 800 rpm, taking the width of the rim to be 5 times the thickness of the flywheel rim is. So we have some options in the question. Now can you please try to solve this question? I hope you can solve this easily. Can you please try it? Can you please try it? I'm very sure that we can do it, but I'm very sure we can do it. I'm very sure we can do it. Please try. Any answer? Any answer? I'm very sure if we try, we can do it, Bida. Please try it. I'm very sure we can do it. So the mass of the rim of the flywheel is 604 kg. Okay, so mass is given in the question. The safe centrifugal stress for the flywheel is 7 megapascal and the material density is 7,200 kg per meter cube. The engine is running at 800 rpm. Taking the width of the rim to be 5 times the thickness of the flywheel rim is. Okay, so basically, this is the question related to the design of the flywheel. Okay, design of the flywheel. So again, in gate examination, they have never touched this zone in the flywheel, but I am very hopeful that they can come up with this punching press or design of this. So if you are aware of this formula, so for designing of the flywheel, we can use this formula. So the velocity is equal to the sigma upon u. So sigma is centrifugal stress, or sometimes we call it hoop stress as well. Okay, it's hoop stress as well. So how we can find this thickness? So basically, we can find this V from this formula, right? We can find this V from this formula. Okay, so what is this V coming out to be? So we have this centrifugal stress as 7 megapascal. So let's take care of the unit. So 7 megapascal means 7 into 10 to the power 6 Newton per meter square. Why changing it into Newton per meter square? Because we are putting the density in SI unit kg per meter cube. So from here, what is the velocity that we are getting? From here, what is the velocity we are getting? So let's calculate the velocity from this. So 7 into 10 to the power 6 divided by 7,200. So ये हो गया velocity हमारी 31.2 meter per second. 31.2 meter per second. So this is the velocity. Now we very well know of this fact that this is pi dn by 60, isn't it? The velocity is r omega, that is pi dn by 60. Now n we have in the question. And we have in the question that is 800 rpm. So from here we can find the diameter of the flywheel, and this will come out to be 800. So we are getting diameter 0.74 meter, right? That is 0.744 meter. So D we are getting 0.744 meter, that is 744 mm. Okay. Now they are asking you the width is 5 times the thickness. Width is 5 times. Width is 5 times the thickness. So mass is given. So do we know that mass is density into volume? I think we all are very well aware of this formula, that the density is mass into volume. So mass is there in the question. Density we have in the question. So volume is what? Pi d into area. Remember, this is the volume of the rim. Okay. This is the volume of the rim. Pi d into a. This is the volume given by pi d into a. So we have now, so we are asked the thickness. So width is 5 times the thickness. So pi into d we have 0.744. Okay, into area. So area is width into thickness. Width into thickness. And this is 604. So we can write width as 5 times the thickness. So if I place here 5t, so we will be having only one variable here. We will be having only one variable here. And when we calculate from here, we will be getting 0.0847 meter. 0.0847 meters. So that is 85 mm. That is what? That is 85 mm. So what is the right answer to this question? Right answer to this question is 85 mm. So again, I hope so in flywheel, sometimes we miss out these concepts like the punching press. We go to see just the conventional way of solving the problem. Okay, but we sometimes miss out. We sometimes kind of miss out this, what you say, we sometimes kind of miss this out. What? We sometimes miss this part out. Okay, like the punching press thing, the this thing of the design of the flywheel. Okay, so don't do that. Now, can we find the mobility of this mechanism? So we have a mechanism as shown in the figure, and we have to find the mobility, that is the degree of freedom. So we see degree of freedoms are getting asked multiple times. So many degrees of freedom questions they ask at so many instances. So can we please try this one? Can we please try for this problem, beta? Let's see what is the answer to this question. So quite simple question. I think if we are preparing for the gate examination, thank you very much. Please do it, beta. I'm very sure that you guys can do it. So this is a very simple question. I am expecting the right answer from you guys. Please answer it. Abhay, very good, beta. Very good. You have given me the right answer. Okay, so let me solve this problem now. So very simple question I have placed. Okay, so this is, let's count the number of links here. So we have one, 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 one. Okay, so this is two. Let's say this is three. This is four. This is five. This whole is six, and this is seven. So how many number of links we have? And do not forget to add this slider. So how many number of links we have? We have 8 number of links. We have 8 number of links, right? Now counting the joints, so we have 2 links connection here, so 1 binary here. 2 links are connected here, so 1 binary here. 3 links are getting connected at this joint, so this is our ternary joint, that is 2 binary here. Do not forget to take this sliding pair, 1 binary. Then here 2 links are getting connected, 1 binary, 1 binary. Here again 1 binary. Here 1 binary. And here as well 1 binary. So we have how many joints? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So number of joint is 10. There is no higher pair in this question. So we are very well aware that the mobility is 3L minus 1 minus 2J minus H. So we have 3 into 8 minus 1 minus 2 into 10 minus 0. So what we are getting from here? So we are getting degree of freedom as 1. So is it clear to everyone or not? Please answer me. So do we have doubt in any of the question, Vida? Do we have the doubt in any of the question? If we have a doubt, you can ask me. All right. So I hope that this session is beneficial for you. You find this session beneficial. and definitely it is going to help you out in your preparation. So thank you guys, thank you very much, and do not forget to subscribe the channel. In case of any query, you may ask me now in the live chat session. I'll be happy to help. Otherwise, let's end the session and we can meet in some other session as well. Okay. So I am hoping that this session you find useful for you. So please subscribe the channel. Please do not forget to subscribe it. Please do not forget to share the video with your friends. Okay. So thank you. With this, we'll see you in some next session. Thanks a lot. Do not forget to subscribe.